Hi, and welcome to the e-learning materials guide of the Defacto project. I'm Carla Sebastiani from Sustainable Innovations. Among the e-learning materials that the Defacto project has produced, we have two white papers, which are the white paper of driving innovation in battery cell design and manufacturing via multi-physics modeling, and also the outcomes and conclusions towards an innovative batteries model. We'll see a little bit more into detail what each of these materials contain in a little bit. And then we have two interactive maps that were developed using Genially, which is the Defacto's exploitation roadmap, and also the stakeholders roadmap for the Defacto value chain. So starting with the first material, we have the first white paper that we produce. This is a white paper that contains more or less the context of the project. It shows a little bit of the reasoning behind Defacto, why the consortium chose to pursue this specific project. So we start with why Defacto. As you all know, as the world and especially Europe is embarking towards a net zero emission road, because the European Commission has set a goal to get to be net zero by 2050. So of course, the electric vehicles have emerged as a crucial solution to achieve this target. So the success of these clean mobility solutions, of course, also depends on the development of advanced battery technologies that can meet the demanding requirements of these electrical vehicles. So this is why projects like Defacto were born. And the main goal here is to make more time and money efficient battery simulations, of course, with the final goal of boosting new technologies and also boosting the development of cutting edge cell and battery manufacturing. So a little bit on the European context, this graph is taken from EV volumes. Here we can see that basically the EV market is growing and is growing fast, and it's also forecasted to keep doing so. So currently the transport sector is one of the largest contributors to greenhouse gas emissions in Europe. So of course, it is a key sector to focus in order to get to these climate neutrality goals. This graph takes the first half of 2023, and it is important to mention that one of the main drivers or boosters at the moment is that the leading nations that represent these markets are, of course, let's say, applying various policies and incentives for the EV adoption. So this is why the market keeps growing and is expected to keep doing so. In this document, you will also find the most relevant related policies. Here we have the Batteries Directive, for example, which is related to batteries and accumulators, and it was put in force regarding the manufacture and disposal of batteries in the European Union. We also have the Eco Design Directive, which it's intended for eco design and sustainable products. And the idea is to create an approach for more environmentally sustainable and circular products. We also have the REACH regulation, which is regarding the registration, evaluation, authorization, and restriction of chemicals in Europe in order to protect human health and also the environment from the risks that can be related to the chemicals. We also have the Strategic Action Plan on batteries specifically, which is a comprehensive framework of regulatory and non-regulatory measures to support all segments of the battery value chain. Also, the list of critical raw materials, which are, of course, crucial to Europe's economy, and it is very important to maintain a reliable access to these materials, and this is a concern on the European Union across the globe. So to address this change, the European Commission has produced this list, which is updated on a regular basis. Then we also have the European Green Deal, which is everything related to climate change and environmental degradation, which is, of course, a threat for Europe and the world at the moment. And to overcome these challenges, the idea is to, among other things, ensure net zero emissions by 2050, as we have mentioned before. And finally, the Fit for 55 package, which is a set of proposals that is meant to revise and update all EU legislations and policies in place to make sure that they are in line with the goals of zero net emissions by 2050. So this is important to keep all of this in mind, and you can find more detail, of course, in the document. And on the last part of this document, we have, of course, a little bit of the introduction, right, to the Defacto's approach, which is the multi-physics and multi-scale approach to modeling, and also a little bit on the project's ambition and the partner's ambition for the results of the project. So as you know, during the development of high-performance cells, there need to be many experiments that need to be carried out in order to formulate the electrode materials, to determine cell architecture, prototype scaling up, and testing. So multi-physics and multi-scale are quite new domains that can optimize the cell development process, and which can also consider many interactions of different variables in very complex systems, which is the case for lithium-ion cell batteries. So in Defacto, we have the multi-physics modeling approach, which is the detailed investigation of these complex physical interactions and heterogeneous performance in multiple layers of lithium-ion cells. These models will basically help to choose the best design parameters to improve the cell performance. Then we also have multi-scale modeling, which focus is the analysis on all range of reactions at cell level from micro to macro scale, with the goal to integrate the data of integrate interactions occurring at different length and time scales. In order to do all of these, to consider this approach, Defacto has developed multi-scale and multi-physics modeling tools to improve the material, cell, and manufacturing process behavior. The goal behind all of these, of course, is to drive research and development, and to also achieve cost reduction and performance improvement, specifically of lithium-ion battery cells, in order to help the adoption of these technologies to fulfill the requirements of electric vehicles. Then regarding the second material, which is a second white paper, which is the outcomes and conclusions, this is centered more around Defacto's results and innovations. So here we have a very brief description of them. But of course, you can find more detailed information in the document. But we'll go briefly over them. We have the adapted STOR database. This is basically a database that gathers valuable data that is fed from the modeling and simulation data from the project. We have the new powder and particle geometry libraries. This is a library with the methodology to build high fidelity discrete element libraries to accurately represent fine powders. Then we have the processing model for tailor-made electrode design. This is the adaptation of the process and formulation parameters, specifically during slurry mixing, coating, drying, and calendaring to obtain specific and desired properties. Then we have the multi-scale simulation tool of the filling process. This is improvement of electrode and electrolyte designs for increased wettability and cell performance. We also have mesoscale and cell scale battery model. This is a simulation chain going from molecular scale to cell scale, and it also includes mechanical effects and aging. Then we have the lattice-Boltzmann model for flowing battery components. This is used for mesoscale simulations at pore level, allowing improvement of process conditions during the filling process. And then we have the optimization software for control and fast prototyping. This is taking all the know-how from the project and also the models and optimization algorithms to offer consultancy services. The idea is that this can be replicated for other chemistries that are not necessarily the ones used for the project. And then let's say that encompassing all of the project results is the project software, which is made of two tools, the time-adaptive Defacto reduce P4D tool and the Defacto reduce order model optimization tool. This is taking a 3D resolve model as a base and using homogenization techniques to produce a continuum pseudo four-dimensional model, which is the P4D, which is derived and numerically solved using finite element techniques. Then to produce simulation results in a more time-effective manner, a reduced order model was also developed, which receives direct input from the de facto full P4D model, but can offer the results in a considerably shorter time. In this document, you can also see information regarding the project partners in case that you are curious on who is working on the project. And you can also see their specific collaborations throughout the project lifetime in case that you are interested. Then as a third material, we have Defacto's exploitation roadmap. The idea of this material is to show the same result that we saw in the other materials, but to see how they have evolved basically during the project lifetime. So in the color dark blue, you can see, let's say, the development during the project, during the Defacto. And then in green, you can see let's say the next steps in order to get to TRL9. So here you can see that the project results got for around TRL5 to TRL6. And this is an interactive document, meaning that you can click on each of the elements and get more information. For example, you can see for each result what stakeholder can benefit from that result. If you hover over the icons, you can see all the related information. And then finally, the last material is stakeholders roadmap. Here we address the same stakeholders from the material number 3, which is the exploitation roadmap. Here you can get a little bit more detail because the exploitation roadmap, let's say it's a quick overview of the project results and the impacts on the stakeholders. But here in this material, you can see more, let's say, longer explanation on how these stakeholders can benefit from each of the de facto's innovations and results. So it is a very, very interesting map, especially if you are an interested stakeholder. Here you can have a good idea on what de facto has to offer. So this is it for the training video. Thank you for watching. And if you have any questions or you need more information, please don't hesitate to write an email to info@defactoproject.eu, and we will be happy to reply and to answer your questions. Thank you.